All right, so we're now to talk about hacking backend components on websites. And so we're going to command injection. You did this in an earlier project where you had a ping form and you could just add a bash command along with the IP address. And that's what happens here. Sometimes you have APIs that take requests over the internet and then they do something on the machine, and they might do that with command line commands. Like I said, the more professional way to do it is to write all your code in one language. But if you're sloppy, you use one language to create a line of code, which is then interpreted by a command processor, like the bash shell command processor. And if you include user data in there, then you get command injection vulnerabilities. So here's a Perl script you might have on the user that is going to decide how much disk is being used by a directory. So use the du command, and then you have a command, and then at the ultimate, the directory comes from the user. So this is just like the ping vulnerability. You have a shell command, and then you put a parameter that came from the user, so the user can just put in, if they put in a real directory like public, then you'll get information about how big the objects in public are. But if they put in public and then a pipe and then another command like cat etch password, then it'll do that. So this is the same kind of command injection you've exploited in the projects. Since the script created a line and fed it to a different environment, like the bash shell, you can inject bash shell commands. This happens to quite a lot of real systems. It happened to HP, OpenView, and so on. It happens over and over. It's not just theoretical. You can inject into ASP as well. Here you are again. It's doing some kind of directory, and the directory name comes from the user. So once again, that means you can put in you use this thing and put in a directory here. So you put a directory here. Here's the default. And if you put in ampersand ipconfig, that is how you put a second command on the same line in Windows shell, command shell. And so you get an ipconfig down here with an IP address. Just showing you the same kind of command injection. And in PHP, you can have a stored search, but you're trying to do some kind of function like search, and they're doing it with a shell command. You do that with the eval function. Eval will execute this search. And eval is one way to create this problem of command injection. It's where you take some text that's been created by PHP and you pass it again to the shell to execute as a shell command. So, all right, so if you want to find these things, any user control data might be used to construct commands. Typically you use semicolon, pipe, or ampersand to inject, to indicate that there's a second command on the same line. Backtick sometimes helps, cause immediate command execution. And so you might have blind command injection, where you send data and it's actually executing the commands, but you can't see the output. This is quite common. So you can detect it the same way you do with blind SQL injection by using ping or something to cause a time delay, or by making some kind of back channel, another kind of network connection, or writing to a file you can see. So here's an NSLOOKUP vulnerability. An app passed user input to NSLOOKUP to look up a URL, look up a domain name. And so they blocked ampersand and pipe, but they didn't block greater than. So an invalid domain name causes an error message that includes the domain name. So you can do something sort of like stored SQL injection here. You can do an NSLOOKUP of this script code greater than path to executable file, and that will put this error message in the file. Can't find the script code NX domain. So this will you'll run the script and write to a file. You'll get an error message, and then you can browse to that file to execute it. This will create an executable file. So there's various tricks that work this way. To bet you have to pay, yeah, I imagine, yeah, that's right, Bruno. In general, when any kind of gambling, you have to pay. And yeah, that particular site seems pretty rudimentary. Most of them have more complicated floating odds. All right. So if you want to prevent this, you shouldn't be calling shell commands directly. It's an unwise thing to do. If you want to do that, don't take input from the user directly. Just have a list of possible results and only allow your known good results to get in. And the other way is to use APIs instead of passing parameters to a command shell. Write scripts that do whatever you're trying to do without using direct system commands. It's better practice. Don't pass user input into dynamic execution or include functions. If you feel like you have to, then you filter it with allow listing. Only allow known good stuff. Yeah. All right, so then you can manipulate the file path with traversal or inclusion. These are common ones. So traversal, you have a function that displays a file name in the browser. File name equals kira.jpg, and so you just use .. to move up, and then move to a different file like windowswin.ini or something. You can replace this file name with a path that goes to some other file, and if there isn't any kind of restriction on the file name parameter, and there aren't any user permissions restricting what files the web server process can get to, then you can see files that were supposed to be private. So you might be able to read or write to files, so you might be able to read passwords that are stored in a file or logs, or overwrite security critical things like configuration files, binaries, so you change the operation of the operating system. You can monitor changes to the file system. FileMon will do this, now Procmon, Ltrace, Strace, or Tripwire on Linux. These are programs that can tell you if your files are being changed, which is one way to detect this kind of attack. And if you want to find this while you're finding vulnerabilities on a website because you're doing a pen test, then just try injecting a unique string in every parameter, like traversal test, and then go to your file system monitoring tool to see if any file anywhere has been created with that string in it. And so here's a successful path traversal attack. The file name is .. and then windowswin.ini. So you see this Windows file, which is of course not what the developer wanted you to see. So if you, there may be obstacles. You should try .. and .. because one of them might be filtered but not the other. You can URL encode the dot and the slash and the backslash to try to pass filters. You can try 16-bit Unicode encoding, or even double URL encoding, where it has to be decoded twice, %25 decodes to %, then %2e. And you can use UTF-8 Unicode encoding, and you can even have overly long Unicode encoding, which is technically invalid, but it is accepted by some devices. And you can also try this thing we talked about before. In case they're filtering out .. you can put .. inside .. And if they didn't put it in a while loop and keep deleting it until it was gone, but just delete it once, then one deletion pass will leave you remaining with what you're trying to get, .. You can also put null characters in. So some systems will ignore the null character and decide this ends in .jpg. Other systems will respect it and end up with boot.ini. So you can make a file that looks like an image but is in fact referring to a configuration file that you want to read or write to, sort of thing. How to just confuse the systems for defenses. So if you can read, then you can try to find password files or configuration files or include files, which often contain credentials, like I was mentioning in the news, or data sources, source code, log files. All these things may contain useful information if you can read them. And if you have write access, then you can gain full code execution by writing to some file which will eventually be executed. For example, startup folders. When a user logs in, any scripts in their startup folder gets executed. So if you write a script there, then some script will run when that person logs in. And you can modify FTP daemon files to execute a command when the FTP connection happens. Or you can write to web directory with execute permissions and then just go to that URL. So these are various ways you may be able to turn a write access into execution. So if you want to prevent these things, of course, it's the same thing. Don't pass user-controlled data into any of the file system functions. If you must, then only allow the user to choose from a list of known good inputs. If you must allow them to submit file names, then there are defenses here. After you decode and decanonicalize them, which means interpret things like %25 and so on, then check for forward slashes, backslashes, and null bytes. If you find any of these things, stop. Refuse to take the data. Don't attempt to sanitize it and go through. And use a hard-coded list of permissible file types, hard-coded directories where they must be. These are defenses to help limit the risk here. And you can use file system APIs to verify that the file name is okay and that it's in the expected directory. There are tools like Get Canonical Path that will get you the official path, right from the root, and you can compare that to whatever they're sending you and make sure that it matches. And you can run your app in a chroot jail. A chroot is a defense a lot like a virtual machine. Before there were virtual machines, you would launch something in moving the root of the Unix file system into a folder. So now you have only a few commands available there, commands you copy into there, so you can run an application by having the necessary functions it uses available, but it is limited to only reach the contents inside a certain directory. It can't possibly traverse out and access other files. Yeah, lots of political text today. All right. So file inclusion is where, now typically you have include files in your scripts. I certainly do. So if you want to include a file, you put in an include statement in whatever language you use, and then if you have some master file with information you use in many programs, you just write it once and reuse the code. PHP allows this, and in PHP it can load from remote servers. So here we got a parameter, country equals US, and the application will now include that country.php. So we've got some kind of country-specific information in a series of files like US, UK, India, and whatever. And so it's going to include it here. The problem is this is under the control of the user. It goes there. So the user could put in a URL that goes to a remote attacker, a remote site where they have malicious code, and it will now be included. So this gives them an easy way to include malware in your PHP file. And then there's local file inclusion. Now this was remote file inclusion. The developer intended for me to load something from the local system, but I was able to trick it into loading it from a remote system. Here's local file inclusion, where you can change the name of the file and the path to it, but only to files that are already on the system. So you'll have to find files that already exist on the system, and you may be able to find useful things to point to. So if you want to find these things in every parameter, insert a URL on a server you control and look at the server logs to see if you're actually able to get any requests to go to the server. A non-existent IP address will have a time delay while it times out. And if it's vulnerable, then try putting a malicious script on your server and fetching it. And to find local file inclusion vulnerabilities, try pointing to a known executable, a known static resource, a sensitive resource, traversal to another folder. These are just things to try to see if any of these things work. Many of them may be blocked by one defense or another, but this is why defense is so hard. All you have to do is find one mistake, and everybody makes mistakes. Let's try Kahoot. Well, they're here. They're just, wait a minute, I'm not in the right place. All right, library. Favorites, there we go. Should be in the favorites list. 129S, there we are. Chapter 10A, all right. Try to make sure the number remains visible. All right. Good. Okay, I'll turn on the display. What's that? Don't understand. Okay, well, after this, you want help? Yeah, I can help you after the lecture. Okay, okay, good. All right, good. All right. So let's do the Kahoot. All right. That should come up. Yeah, all right. All right. So which defense will detect file system modifications on Linux? All right, good. So that is Tripwire. Procmon is Windows. Tripwire is the product that runs on Linux. All right, so what character will perform command execution immediately? It's the backtick in Linux, and let me just show you this. This is something you may not know about. A lot of people love this. I find it confusing. So if I use echo, I can echo A, and I can echo IP, IPA, and if I echo backtick, IPA, backtick, then it'll execute this command and show me the results. I don't have IPA. I got to use ifconfig on Linux. ifconfig en0. There we go. So this is the backtick executes this command immediately and adds it as a text to be interpreted with the command before it. A lot of people love that backtick thing. I don't like it. It's hard to understand. The old-fashioned way to do it, which I prefer, is to use dollars parentheses. This I use a lot. Anyway, all right. Anyway, all right, so which defense puts the web server in a restricted file system? Yeah, that's your root. You move the root of the file system into a folder, and now the web server can only see things in that limited area. A little bit like a virtual machine. All right, which vulnerability is caused by eval? That's command injection, yeah. Eval evaluates things with shell commands. All right, let's take a look at the rest of this. So, there's these things called XML external entities on services using XML. You can define user-defined shortcuts. So in a search, you'd send a search like this with some XML structured data like search term, nothing will change. This is the structure of the thing you send up. And a server will respond with the results. A little bit of XML. This is commonly used for things like mobile apps, where you want one little bit of information from the server. But XML external entities let you do this. You can define an entity called testref, which will have this value. So you can have a named object, and you can define the value. And that means ampersand testref will be replaced by the value here. But since this, you can use active scripting in there too. So here's XXE's explanation. So here's request is going to have foo and /foo, and the server is looking for that and going to echo it back, hello world. But if I want to do an injection, then I put in element foo any, entity bar world. I define these elements, and now I can do hello bar, and where it sees bar, it'll put world in. So this is just, you can make a named variable that points to data you define up there. And this would be harmless if all you could do was static text like that. But what you can do is you can define bar to be world, and then T1 to be 2 bars, and T2 to be a bunch of T1s, and T3 to be a bunch of T2s. So now a T3 will expand into just a whole lot of hello worlds. This is commonly how it's used for denial of service attack. By defining a few of these, you can make a huge number of repetitions of something, which can overwhelm the server. And here's another one. You have a file. You're defining here XXE to refer to that file, and now it will, you put in here XXE, and when it does it, it will execute this system command, and display the contents of that file. So you can get some degree of code execution from XML entity injection. And here's another one. This is remote file inclusion. You put in XSE system, and now it tries to load this file from a remote server, and there it is. It takes a remote file and bounces it off the server, so you end up with effectively remote file inclusion. All right, so you reference an external entity, like I say, we've done that before. You reference an external entity either on the file server or off the server, and therefore the response will include the contents of that file. All right, so here you can, for example, connect to an email server. You can use the machine that has this vulnerability to scan for other machines on the local network by sending requests to various ports. Now, that you might see a way to get access to things that cannot be accessed directly from outside the network. This is why it's valuable. If you can get control of any device inside a network, then you have a privileged position to scan the network. Typically, only a few devices are visible from the outside because of the firewall. That's why we were just talking on Pulse Security podcast about an attack that takes over the printer. And you said, well, what good is it to take over the printer? And this is one reason. Now you have a place where you can launch attacks from inside the network to get to the internal devices that don't connect directly to the internet. Anyway, and you can make a denial of service, of course. This will make an infinite stream of random bytes. You try to print out the contents of the dev random file, and on Linux, that's just an endless stream of random bytes. So that's a simple denial of service attack. It will just be start a process that will just run forever, creating an endless amount of data. SOAP, we talked about before. It's a protocol that uses XML. So if you're doing a banking app, you might send this request from account to account, amount, and submit to make a transfer from one account to another. And so back when you send it to the server may send a SOAP message to another server out there, and that will have this information from account, amount, to account, and then it will have a parameter called cleared funds, which is something determined by the server whether you in fact have enough money to make this transfer. You didn't create this, but the server will make it. But if you can figure out what it is, then you can do an injection here, where you put in amount, and in the amount field, you add extra characters, including this cleared fund equals true. So you send it there, and the resulting SOAP message will contain this cleared fund equals true, and it will have comments to comment out the real one from the server, so you might be able to trick the other server into thinking you have the funds when you don't. All right. That's the sort of thing. All right. And if you want to test it, you can just put in an opening comment tag, and therefore it should be rejected, but it might not be. Boy, this is what people are telling me, so many voting messages now. Anyway, so try injecting XML medical characters like less than, greater than, opening comment character, and see what happens. Just try these various injections, see what's get in, same way you test through these other things. And sometimes the parameters are stored and sent back to the user, so you can send some objects and see if the reply contains test or the injected tags. Change the testing for stored SOAP injection. And you can, like I say, you can inject a opening comment and a closing comment, and if it works, that will comment out part of the code the developer put there, and that might have interesting effects. So if you want to prevent this, you have to filter the data, HTML encode the meta characters, like less than, greater than, and slash, turn them into these. All these is codes that will make it look like that on the screen, but they will not be interpreted as meta characters. So this is how you defang injection attacks. And as you inject into backend responses, there's HTTP redirection and HTTP parameter injection. So if you have a URL that includes data from the user, like here's a location parameter, and that is URL controlled by the user. So now I can give it a different URL and cause the server to make some request to some other server. So I could tell it to go here on port 22, and now it will connect to that, and I'll see the response. And the SSH protocol has a mandatory header, so you'll see a header there. So there's one way to connect to a backend SSH server from inside the network from the web server you compromised. And so again, you use an app as a proxy. Once you're in, you can connect on the internal network and bounce attacks off one manipulated box to get to other boxes inside the system. And parameter injection is where you send a parameter in. So this request goes to the server with from account, amount, to account, and submit, and it creates a request on the server with the same kind of information from account, amount, and to account to be sent between things. And so the front-end server, it's just before, I can add cleared funds equals true into a parameter here. So when it gets passed to the next server, it will have that parameter, which came from the user, not from the server. It's fundamentally how all these attacks work. You trick the server into misunderstanding something and thinking it came from some authoritative source instead of an unauthoritative source. So now you're going to have this cleared funds equals true on the request, and you might get away with something. Another one that's pretty fun is parameter pollution. If you define the same parameter twice, the behavior is undefined by the request for comments that specify the rules for the internet. So sometimes it uses the first, sometimes the last, sometimes it combines them together, sometimes it creates an array containing both values. So the original request was from amount cleared funds equals false and to account. So now I make a front-end request, I add cleared funds equals true in here. So now the front end receives this cleared fund equals true that came from the user. The back end puts, could make this added parameter there. That's one possibility. But it could also have two parameters where the back end adds another parameter set to false and mine is set to true, and it might believe mine. So URL rewriting is common, especially on Apache servers. This is how you implement a lot of functionality with sort of regular expression type URL rewriting, and that's dangerous. So you can trick it. So here's an Apache rule: rewrite the request, rewrite rule pub user to go here. So I'm going to take public user is going to go to a user manager.php with name equal here. It's going to take part of this and interpret it as parameters. So it's going to take pub user Marcus and turn it into inc mode equals view name equals Marcus. So this is how you implement RESTful stuff. I never liked this stuff. I talked about it before, where you put parameters in like they're folder names. For some reason, people do this, and this is what you have to do at the other end. You have to turn it back into the canonical structure, but it does it with a rewrite rule. But the problem is you can exploit that rewrite rule. So here's the attack. Marcus %26 mode equals edit. Now it will change to this, mark equals mode equals edit. I'll now be able to edit a file I was only supposed to be able to read. I was able to inject a second parameter because this is interpreted as just part of a folder name. And the rewrite rule turns it into a parameter. So, all right. You can inject into mail services. Apps often send mail for various reasons, and they include user-supplied information, like you're forming a complaint form or an error message, and therefore you can do injection. So here's a type feedback form where I put in your email address, subject, and then comment. And so it's going to send this to the, but the thing is, SMTP is a very simple protocol where you just separate things with carriage returns. So you can inject things here. For example, I could put a BCC here. If I catch it with burp, I can just add another header line here. And now it'll send an extra copy to somebody else. So now if I can do that, I can use your server to send spam. I can send an email from your server to somebody else that doesn't want it. So this feedback request from subject file it was feedback, message equals foo, creates this from to subject. And then the message is foo, which goes here. And so if I inject into the subject field, I can take the subject field and then I can put in two carriage return line feeds, carriage return line feed, and have a second email coming from there, which is now going to go from here and then send people spam about Viagra. You can have two email messages in the same request. And the second one is completely under my control. So I can send spam from your server. And this is the resulting spam. Something about Viagra, going to somebody, cheap Viagra, etc. So you'll find these injection flaws, consider both Windows and Linux new line characters. And if you want to prevent it, same old thing. Anything that comes from a user, you have to validate it. Make sure the email address is correctly formatted. Make sure that there are no new line characters in the subject. Make sure that if there are no lines containing a single dot, because a single dot ends an email message, and then there can be another email message after it. And so you shouldn't allow the user to terminate the message. You should only allow the developer to put in the end of the message. So that's the game. And I know this may seem like a lot of details, but it's good to see them so you can spot them later. And you'll see a lot of these in the project in the Web Security Academy. So 10B is here. All right, that may be all there are. All right, so which attack sets the same value twice? That's called parameter pollution. All right, which attack is likely to work on AJAX applications? It's XML. AJAX stands for Asynchronous JavaScript and XML, and it's used for dynamic pages like Google Maps. And so since it's using XML, it's liable to fall for XML external entity in expansion. All right, which attack injects XML and HTML comments? Soap injection did this. This exploits a bizarre thing about the web that you typically have files that contain multiple languages in the same file. Active code and formatting commands in the same file, which people have been complaining about for 30 years is a bad design decision, but that's the way the web works. All right, and which one uses a line containing a single dot? That's SMTP. A single dot is the end of a message in SMTP, so you can use it to create two messages where you're only supposed to be allowed to send one. So let me stop this recording.